Okay, so here's your diagram, and it tells you that these that A, B, C, and A, D, E are similar. So triangle A, B, C, and this is how you write similar, is similar to triangle A, D, E. And it wants you to find the length of side CA. Okay, so CA is this piece of the smaller triangle right here, so we're going to call that X. And because they're similar, then you can use a proportion to solve this. So you can pick X and its corresponding side to the bigger triangle, or X and another side from the same triangle. So it's up to you. What side does X correspond to? Okay, 15, right. So this side corresponds to this side. So X over 15 equals, so now because we chose X up top, we have to now pick a number from the smaller triangle so that it matches the, 3 is your only choice. And, oh, I forgot a number here. Okay. So you have this 9, so if we chose this 3 corresponds to the 9, so we can make another fraction there. Remember I mentioned that if you want, you can reduce the fraction, or you can just go ahead and cross-multiply, whatever you feel comfortable with. But if we reduce, we have X over 15 equals 1/3. And then when you cross-multiply, 3X equals 15. So divide by 3, X equals 5. Good. All right, so this is the measure of the side CA. Any questions there? A baseball diamond is actually a square with 90-foot sides. So they gave you a picture here. Okay, so they have first base, home plate, third base, second base, and then this side is 90 feet, and this side is 90 feet because it's a square, and then they have this labeled right here as X. And so it says, what is the distance from home plate to second base? So they want you to figure out that distance right there, X. So notice when they drew this line across the square, they created 2 types of triangles. Well, not 2 types, 2 triangles of the same type. And so what kind of triangle do you see in there? A right triangle. Okay, it's a right triangle because it's got a right angle there. So our square has 90-degree angles. And so therefore, if this side is 90, then this side is also 90. And which side of that right triangle are we looking for? Think of hypotenuse, right? The hypotenuse. So we can use the Pythagorean theorem here. And we know that each leg is 90 feet. So substituting in 90 for A and B. So 90 squared is 8,100. Is that correct? Okay, add these together. And we get 16,200 equals C squared, correct? And so now we have to take the square root of both sides. And I know in my book it gives 2 answers. The exact answer with a square root still in it, as well as the decimal approximation. So let's go ahead and remind ourselves how to do both of these answers. If we need an exact answer, then one way you could have done it is tree factorization. Notice that we've got 2 zeros, so this is 162 times 100. Then we can split up the 162, and we know 2 goes into that, 81 times. 81 is 9 times 9, and 100 is 10 times 10. Even though we're not all the way down to the primes, you can, if you have two numbers that are the same, you can stop there and say I've got a pair of 10s and I've got a pair of 9s, but I've got a little 2 that's all by itself, so it's got to stay under the square root. Okay. Say that again? Well, it depends on how they want the answer. See, my book is giving it in both answers. So if it says leave your answer in exact form, then you have to do it this way. And so you can take out a 9 and you can take out a 10 because you have a pair of each of those numbers, but you have to leave behind the 2. Anything you take out, you multiply together, so you get 90 square root of 2. Now, if it says that it wants a decimal answer rounded to so many decimal places, then you're going to go straight for the calculator. And so you can start straight from the square root of 16,200. Okay, so my calculator gives me 127.27922 and so on. It's going to go on forever with no pattern because it's an irrational number. So if we round to the nearest tenth, then we get approximately 127.3 because we're rounding right there, and the next number is 5 or greater, so we're rounding up to 3. So any questions there? A regular garden bed measures 5 feet by 12 feet. Sorry, not regular, rectangular. A rectangular garden bed measures 5 feet by 12 feet. A water faucet is located at one corner of the garden bed. A hose will be connected to the water faucet. The hose must be long enough to reach the opposite corner of the garden bed when stretched straight. Find the required length of hose. Okay, so we're going to have a water faucet on one corner, and we want the hose to be able to reach to the other corner when it's straight. Okay, in a rectangle, what measure angles do you have? So right here, this corner and this corner is how many degrees? 90 degrees. So again, we formed a right triangle. Now we are going to talk a lot more about rectangles in the next section, but that's what they sort of wanted you to remember from maybe previous math classes and so on. So you have formed a right triangle. And notice that if this side is 12 feet, then this side is also 12 feet. And so which part of the right triangle is missing? The hypotenuse again. So we can use Pythagorean theorem whenever we have a right triangle. We were given the legs, so substituting in a 5 for A and a 12 for B, we get 25 plus 144 equals c squared. So that gives us 169 equals c squared. Take the square root of both sides, and the square root of 169 is 13. So 13 feet is what you need that hose to be. Okay, so we're talking about polygons, quadrilaterals, and perimeter. A polygon is any closed shape in the plane formed by 3 or more line segments. A regular polygon is a polygon whose sides are all the same length and whose angles have the same measure. Okay, so if your polygon is regular, all the sides are the same, all the angles are the same. Okay, we talked about one polygon, which was a triangle. And so a regular triangle would be the equilateral triangle because all sides are the same and all angles are equal. Now, these do not have to necessarily be regular. I keep forgetting to change this slide. It's just if it is this shape, then it has this many sides. So a triangle has 3 sides we talked about. Quadrilateral has 4. A pentagon has 5. A hexagon has 6. Heptagon has 7, and an octagon has 8 sides. You want to be familiar with these terms because if you're asked, to find something about a heptagon, you probably have to know that that has 7 sides. So you want to make sure that you know these terms and how many sides those polygons have. Okay, so we're going to focus a little bit more on quadrilaterals in this section. And so we have several types of quadrilaterals. So this means that all of these shapes I'm about to tell you all have 4 sides. A parallelogram is one in which both pairs of opposite sides are parallel and they have the same measure. So those opposite sides have the same measure. Opposite angles have the same measure as well. The way I like to think of a parallelogram and what that looks like is if you've ever tried to assemble a box or disassemble a box and flatten it out, you get to a certain point where it gets, you've turned in the top and the bottom and it gets real loose. And so once you start flattening out that box, you get this shape right here. Okay, you think about just flattening out that box and it starts going slanted like that, a slanted box. That's what a generic parallelogram looks like. And so note that the opposite sides are equal. So this side's equal to that side. This side is equal to that side. And then opposite angles are also equal. So this angle is equal to that angle. And then this angle is equal to this angle. Okay, a rhombus is a parallelogram with all sides having equal length. So we're basically looking at the same shape, but we have to make sure that all the sides are equal. So you could draw a rhombus like this. Or sometimes you might see the rhombus drawn like this. Okay, more like a diamond. But all sides have to be equal when it's drawn. A rectangle is a parallelogram with 4 right angles. So it's as if you take that slanted box that we drew up top and you just push it so that it's straight. Notice that none of the characteristics change on that box other than the fact that you put it straight so that all the angles are right angles. So it's still considered a parallelogram, but it just has 4 right angles. A square is a rectangle. I know some of you guys have a hard time with me saying that. A square is a rectangle, but it just has all sides of equal length. Now, that statement does not work both ways. You cannot say that a rectangle is a square unless it happens to have all equal sides. But a square has all of the same characteristics as a rectangle. It's just all the sides are equal. All the angles are right angles. Okay, so I get my daughter in trouble a lot with her elementary school teacher because, she comes home with those assignments to identify each shape, and she tells me that's a square, and I said, oh, it's also a rectangle. No, this one's a rectangle. No, but that one's both. And so she goes and corrects her teacher. But, okay, okay, if you wanted to give the most precise answer for that shape so that it describes every detail about that shape with only saying one word, then you would say it's a square. Okay, because by saying a square, you have already identified the fact that it has all equal sides, it has all right angles, and so forth. So if I ask you to identify the shape, then I want you to give the best answer that describes that shape with all its characteristics with one word. Okay, so just to be clear on that. All right, all of these four shapes are considered parallelograms. Okay, because notice that the square is a rectangle and a rectangle is a parallelogram. Now, the square can also be considered another object in our list here. It has all the same characteristics as something else in the list. The rhombus is the one I was looking for, because notice that we already mentioned that it's a rectangle, which means it's also a parallelogram. But notice that a rhombus is a parallelogram with all sides being equal. So a square also falls into those characteristics of being a rhombus. All right, so if you were to give all of the names of a certain object, the square could be all four of those. Okay, but the best answer is square, because by saying square, you know exactly what all the characteristics are. Now, one of these is a regular quadrilateral. The square is correct. Okay, because remember, a regular polygon is the one that has all sides being equal and all angles being equal. A rhombus has all sides that are equal, but not necessarily all angles are equal. Because, notice that even in this first drawing right here, this angle is definitely smaller than this angle in red. So that's not a regular quadrilateral, because not all the angles are equal. But the square is a regular quadrilateral. All sides equal and all angles equal. Okay, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So therefore, it's not a parallelogram. The parallelogram, both opposite sides have to be parallel. So the traditional trapezoid looks more like this. Okay, that's the traditional trapezoid. But it could also look like this. So notice that the point is that only one pair of opposite sides are parallel in both of those shapes. So I like to point out the shape on the right, because if you think about what you see in everyday life in the world, okay, if you go to a downtown of a big city, 98% of the time you're going to find a building that's shaped like the one on the right, okay, that trapezoid shape where the sides are parallel but the roof is slanted, okay? All right, so these are all of your types of quadrilaterals. So one of the things that you're going to have to do is find the perimeter of an irregular shaped object. So notice that this object right here, it's not a quadrilateral, it's not a polygon, okay, because it goes in and then out and so on. So it's not one of the shapes that we've talked about. And notice that you have sides missing. Now, when you're looking for a perimeter, that means that you're looking for the distance around an object. But without knowing all the sides on the outside, you have to do a little bit extra work to figure that out. So notice that in this shape, we have another shape that it's made up of. You can sort of separate this into what shapes. Okay, so no squares in here, but definitely rectangles. We can cut this into a rectangle, and then we have a rectangle on the right, and we have a big rectangle in the middle. Now, one of the things that we know about rectangles is that the opposite sides are parallel, but the more important thing is that the opposite sides have the same measure. So because we know that, then since this side is 3, then this piece right here is also 3. Okay, since this piece is 7, then this piece right here is also 7. And since this piece is 2, then this piece right here is also 2. Okay, that was the easy one to visualize. Now this piece on the right, we still have a piece that's not marked right here. And so if I form a rectangle this way, notice that we don't have that entire left side of that rectangle. But instead, I can make a couple rectangles. So what if I split that there as well? All right, so starting from the bottom right, if this is 3, then this is 3. Now, we didn't really need that piece for the perimeter, but we needed to figure out the rest of this, because if this is 5, then this piece is 5, and this entire piece is 5. Okay, so we really need this shorter piece in red. And so if the green line is 5 and the blue line is 3, then how much is left for this little red piece here? 2. So this piece is 2. And so now looking at this rectangle up here, we know that this side is 6, so therefore this side is 6. So altogether this side right here is 8. Okay, so that whole piece there is 8. All right, now that we have all the missing sides, we can find our perimeter. Note that you do not need these numbers that were on the inside. We only use that to find the 2. Okay, so adding, let's start from the 5 on the left. So 5 plus 3 plus 6 plus 7 plus 8 plus 2 plus 3 plus 2 plus 7 plus 3. I would agree, 46. Okay, so the perimeter of this shape is 46. You're going to be given lots of, irregular shapes like this where you may have to find a missing side using what you know about the shapes that you're learning in the book. And so, here we use rectangles and knowing that those opposite sides are equal. All right, so the angles of a polygon. The sum of the measures of the angles of a polygon with n sides is found by using this formula, n minus 2 in parentheses times 180. Now, we already talked about a triangle. We know that the sum of all the angles inside a triangle equals 180. So let's test out our formula on that. So a triangle has how many sides? 3. So n is 3. So substitute that in. We have 3 minus 2 times 180. So 3 minus 2 is 1. 1 times 180 equals 180. Good. Okay, so our formula matches up to our triangle. So you can use this formula for any polygon to figure out what the sum of all the angles would equal. All right, let's say that you had an octagon. How many sides are in an octagon? 8. Good. Okay, so n equals 8. Not quite. Okay, substitute 8 into your formula. Right, so 8 minus 2 would be 6, and you have 6 times 180, which equals, okay, I heard 1080. All right, so in our formula, we have n minus 2, substituting in the 8. Everybody following so far? So 6 times 180 is 1080. That's correct. So that tells you in your octagon, okay, so here we have an octagon. That tells you that all of the angles inside the octagon add up to 1080. So if you know what some of the measures of the angles are, then that can help you to find the missing angles, okay, because you know that all of them should add up to 1080. Now let's say that this was a regular octagon. I don't think I drew it regular, okay, because regular means what? All the sides are the same. Okay, let's say that all the sides are the same. If it's regular, that means that all the angles are also the same, is what it's going to, yes. Okay, so you figured out that they would each be 135. How'd you do that? Good. So if it's a regular, then the angles are equal, so divide 1080 by the number of angles, or 8 angles, and they each measure 135. Good. You cannot assume that the polygon is regular unless they tell you that it's regular, or unless you know you can see that all the sides measure the same. Okay, but that's one way to find the measure of the angles in the object. Okay, the first types of questions that you're going to see in here require you to be able to identify certain polygons. So if you're going to identify the polygon, what do you need to do first? Count the number of sides. So how many sides do you see? Okay, 4. So therefore, yeah, you guys don't have 6 fingers on the hand, do you? So, you know, choice 1, 2, 3, 4, 5, 6. So C. Okay, so you're saying C. All right, so quadrilateral because it has 4 sides. Nice work. Okay, other types of problems that you'll see. Are just trying to name characteristics. Okay, so which of these quadrilaterals have right angles? And name these quadrilaterals. So you have to identify by Roman numeral, and then you also have to name them with the correct name. And again, when we're talking about naming them, name them with the best name that describes all of the characteristics. Okay, so you have choice 1, choice 2, choice 3, or choice 4. Okay, yeah, they gave you a tough one here. So choice 1, fantastic. Okay, but it could ask you something like, which one has adjacent sides that are equal? Okay, which ones have adjacent sides that are equal? So you can use the same answer choices here. Do you want choice 1, 2, 3, or 4? Okay, adjacent sides that are equal. So first you have to know what adjacent means. Nope. Touching would be a good, yeah, touching sides, or sides that are next to each other. That's what adjacent means, is to be next to each other. Okay, so choice 1, 2, 3, or 4. All right, I have a majority of 2. So the square and the rhombus. Excellent. Okay, so it could change the question on you as far as what you're looking for. So make sure that you're really paying attention to what those questions are and how that relates, okay? Because notice that on a square, if you take any 2 sides that are next to each other, those would be adjacent sides, and those are equal. On the rhombus, right here, 2 sides that are next to each other, they're equal. Okay, so that's what we were talking about with adjacent sides. Okay, so next question, find the perimeter of the square. Okay, 150 times 4, because you know all 4 sides are the same. So you get 600. All right, so there's always 2 ways to do this. You can do 150 times 4 sides, which you got 600 inches. Or you could do it the long way and say 150 plus 150 plus 150 plus 150. Okay, whichever way you think about doing that. Fantastic. All right, so let's get to some of these irregular shapes. So here it wants you to find the perimeter of the figure shown. So it's more of an L shape. And so what can you cut this into? Some rectangles. Well, okay, yes, you would have one square if you went this way. Good. Okay, well, let's go that way first. So cutting it this way, we know that the top part of the left is 2, and then the bottom part of that left-hand side is 3. So altogether, that side is equal to 5. Okay, then looking at the bottom, we can cut it this way. So if the top is 2, then the bottom piece is 2. If this is 6, then this piece is 6. So this side is equal to 8. And then add up all your outer sides. So starting with the 2 up top, 2 plus 2 plus 6 plus 3 plus 8 plus 5. And what do you get? 26? Everybody agree? Fantastic. Yes, Math Excel's very excited today. Okay, find the sum of the measures of the angles of a 9-sided polygon. The sum of the measures of all the angles of a 9-sided polygon. So, what do we need to solve this? Good, that formula, n minus 2 times 180. Right, since it's 9-sided, n equals 9. Okay, so we get 7, and 7 times 180? Okay, let's see if you're right. Excellent. Okay, so now notice that we have a polygon here where the top side has been extended. And so we have a couple angles that are labeled A and B, and they want you to find what those measures are, A and B. Now it tells you that you're looking at a regular polygon. Good, so use the formula. Well, the formula won't necessarily give us A directly, but it will give us the sum of all of the angles in there. Okay, how many sides do we have? 6 sides. Okay, so 6 minus 2 is 4 times 180, and what do we get? 720, good. All right, since this is a regular, what kind of shape has 6 sides? Hexagon, good. So since we have a regular hexagon, what can we do to find A? Divide by 6, because they're all equal. So take 720, divide by 6, and we get 120. Okay, so angle A is 120. So now what can we do to find angle B? It is on a straight angle. Okay, so I heard 180 minus 120 because what's another thing you would call A and B? Supplementary. Okay, so they are supplementary, so you can take 180 and subtract 120, and that gives you 60. So angle B is 60. Now dividing by 6 only worked because it was a regular polygon. Okay, so A was 120 and B is 60. Good job. Okay, so notice this one is not a regular polygon. Sort of looks like a pencil lying on a desk. okay, or a crayon lying on a desk, okay, on the table. All right, so we need to find A and B again, and you cannot assume that there's symmetry, meaning that you can't assume that because the top one's 140 that the bottom's 140, because you don't know that the drawing is drawn to scale. So what can we do instead? Okay, it's 5 sides, and we can use the formula. And even if you read the first question, it's sort of trying to get you in the right direction. Find the sum of the measures of the angles for the given polygon. Okay, so it's 5 sides. 5 minus 2 times 180. So 3 times 180, which equals 540. Okay, it's not regular, so we can't divide it by 5 this time. So instead, what can we do? Good. So subtract all of the other angles that you see in there because they should all add up to 540. All right, so notice that we see 2 angles that are right angles. So that's 90 and 90, which is 180. So subtract 180. Okay, you can do this in pieces or all at one time. So 360, is that right? Okay, and then we need to subtract the 140. So 220. And then subtract the 80. And you get 140. Okay, so this time it was the same as 140, but I can tell you, the one in the book doesn't come out that way. So, it's not always the same as the other angle. Now, the answer to the first question here was 540. That was the answer to part A. Find the sum of the measures. And then the next question is going to ask you what is A, and that's the 140 that we found here. Okay, so let's go ahead and substitute or type in those answers right now. Okay, so the sum of the measures of the angles is 540. Nice work. Okay, angle A was 140. So then what do we have to do to find B? Okay, good. They are supplementary again. So 180 minus 140 is 40. Okay, so 40 here. Fantastic. All right, notice here we have a shape that has the angles expressed with, the letter X somehow, some algebraic expression in there. So notice that they're not all equal, so it's not a regular polygon. And we have to figure out what each of those angles is equal to, the ones that aren't marked. So what's the first thing we should do? Find the sum of the measures. Good. So use that formula to find what these should all add up to first. Okay, how many sides are in this polygon? 6, and I believe that we did that one already, right? A 6-sided polygon has the sum of the measures is 720, right? Okay, so what this means is that all of these add up to 720. So in order to solve for x, you can add all of these up and create an equation so that it equals 720. So starting with, I'm going to start with this angle here, the x, and go clockwise. So x plus 5 plus 120 plus x plus 5 plus x plus 150. When you add them up, it should equal 720. So now you have an equation, a really long equation, that you can get x by itself. Okay, so getting our like terms together, we have 1, 2, 3, 4 x's. And then adding up our numbers, 120 and 150 is 270. And then with 2 5s, that would make 280. Right? Check my math. Okay, so now we can subtract 280 from both sides. So what does 4x equal? Okay, 440. And then divide both sides by 4. And x is equal to 110. Okay, so that means that these two angles are 110 because they're both equal to x. So therefore, the other two angles are equal to 115 because you got to add 5. Okay, so these are 115. So it's a step-by-step process here. You have to do one step before you can move on to the other step. So it's trying to get you to put all of these things in this section together into one problem. So any further questions there? Okay, so we're going to pick the answer that's 110, 110, 115, 115. Fantastic.